All right, the second lecture of this first unit, the unit of on matter, has to do with properties of matter. And again, I just kind of wrote out all the key points. Again, you can pause the lecture from time to time if you have to, and then write down some of these notes for yourself. This is going at how, when we look at matter, what are its properties and how we can utilize them, just like for the unknown powders lab, how we can utilize those properties to identify what a substance is. First of all, excuse me, uh, there are two basic types of properties, chemical and physical. A property observed without changing the identity of the substance, so changing what the substance is or if its chemical makeup, its bonding arrangement. If that property can be observed without chemically changing it to something else, it is a physical property. Examples of physical properties would be things like color, odor, shape, texture, mass, volume. These are all types of properties I can take down about a material without having to actually change its bonding arrangement. Okay? If I am changing its bonding arrangement, I'm breaking the bonds, it's going to become something else. So by observing this chemical property, what ends up happening is when I'm done observing that property, the material is no longer present. It has been changed to something else. Examples of this are combustibility, flammability, if we burn something, okay, reactivity, mixing a metal with an acid and it begins to corrode. Oxidation would be like tarnishing something. If you cut a banana and it begins to brown, those are examples of oxidation. Rusting of a metal on a vehicle, for example, here in Wisconsin. Then we also happen to have things which are called physical and chemical changes. These are changes that we make to the material that will either change its chemical bonding or not change its chemical bonding. If it's a physical change, we are changing the material, but its chemical makeup, its bonding arrangement has not been affected. Physical changes are examples like boiling point, freezing point. When we freeze something or boil something, we can always melt it back. We can always condense it back to its original state. So any state change is an example of a physical change. Density, it's mass per unit volume. Conductivity, will it conduct electrical current? Malleability, can I pound it or bend it into shape? Those are examples of physical changes. Chemical changes will change the chemical composition, so the bonding will change and therefore it has become a different chemical compound. Chemical changes, examples that would be like burning a piece of wood. We can notice that it's burning, but we can't get the wood back again. Cooking an egg, we know that it does chemically change the egg into something different. The whites become hard and white from the clear albumin that it's stored in. Rusting of a metal. Once a car rusts, okay, we can't get the metal back in. We might be able to polish off the rust and get to some clean metal underneath of it, but we've lost that thickness of the metal if it has rusted. Lastly, another way we can look at property materials is if it's an intensive or extensive property. Intensive properties are also called characteristic properties. These are properties of materials that do not depend upon how much material you have. And therefore, no matter how much you have, it's a constant. Just for example, water. Water will always boil at 100 degrees Celsius. It doesn't matter if I have a small cup of water or if I've got thousands and thousands of gallons of water. While it might take longer for the larger amount to boil, if I stick a thermometer into boiling water, regardless of amount, it will always boil at 100 degrees. And therefore, it's a property that can easily measure and help distinguish if that material might be water. Extensive properties really do not give us an idea of what the material is. Examples of extensive properties would be classically mass and volume. The amount of material, mass and volume. Okay, if I have behind my back something that weighs it has a mass of 10 grams, that doesn't really tell you what it is. It could be anything. Okay, but things like density, boiling point, freezing point, those are all types of intensive properties that can help us identify what the material is. Water always has a density of 1 gram per milliliter. So 1 milliliter always weighs 1 gram. It always boils 100 degrees Celsius. It always freezes at 0 degrees Celsius. Those are intensive properties. An example of intensive property, again, is density. And density is defined as the amount of mass per unit volume. The equation for density is on your blue sheet. It's on the left side of the chem helper towards the bottom. Again, it shows density equals mass divided by volume. Density units are typically grams per milliliter or grams per cubic centimeter. A cubic centimeter would be a cube, which would be 1 centimeter by 1 centimeter by 1 centimeter. A cubic centimeter, if you were to melt that down, would equal 1 milliliter. So a milliliter and a cubic centimeter are equal volumes amounts. They're equal quantities. So density is mass per milliliter or grams per cubic centimeter. Those are the typical units for density. It's interesting that it's a derived unit that I can take two extensive properties, mass and volume, but when I divide them and get a ratio of that mass to volume, it gives me a constant. And again, for water, 1 milliliter of water weighs always 1 gram, 1 gram per milliliter. Something you might have learned in middle school was this density triangle. It's a way that you can easily convert the density equation into whatever form of it you need to solve a specific variable. We can see here, if I'm trying to solve for density, to get density, you'll notice that the mass is over the volume. So that gives me the equation, mass over volume. So if I want to find the density, I just simply divide the mass of that object by its volume. Vice versa, if I want to know the volume of the object, you'll notice that m is over d. So to find the volume of the object, if I know its density and its mass, I can divide mass by density, and that'll give me my volume. If I want to know the mass of the object, now the density and the volume are on the same level, and therefore that tells me I need to multiply them. The mass of an object is simply equal to its density times the volume of sample that you have. So you might find the density triangle to be something that is very helpful for you in this unit as well. All right, I had to run and grab my calculator quick. I forgot that there are some math problems in this lecture. So you are going to have some mathematical problems with your second homework for the year, and mainly this is going to involve density. So a student is given a task of measuring the density of an object. He finds the mass to be 12.85 grams and the volume to be 5.45 milliliters. If you want to pause the lecture right now and go ahead and try to do this problem, please do, and then I'll go through the answer and see if you have it correct. All right, because we're trying to find the density, I'm going to use the equation that I have up above, where to find density, I need mass divided by volume. This is about as simple of a problem as you can get. I would hope nobody would get this wrong. All I need to do is simply divide the mass by the volume of the object. I'll punch it into my calculator. And we get 2.36. It really doesn't matter where you round the number. I usually always round to 2 decimal places. So the answer would be this object would have a density of 2.36 grams per milliliter. So every milliliter of material would possess 2.36 grams of mass. Okay. The next problem, it says aluminum is known to have a density of 2.69 grams per cubic centimeter. A student has 32.6 milliliter piece of aluminum. How much mass does it have? Again, we are asked to find mass. So if I want to find mass, I look above, and all I have to do then is, if I use the density triangle, is I just need to simply multiply the density by the volume. So 2.69 grams per cubic centimeter times the volume. Now 32.6 milliliters, because I know up here that 1 milliliter is equivalent to a cubic centimeter, I know 32.6 milliliters is also 32.6 cubic centimeters. So all I got to do now is multiply 32.6 cubic centimeters times 2.69. Now, what my students don't often do is they don't look at units, which is very important. Maybe not so much early on, but later as we get more difficult problems, we will. Because it's per cubic centimeter and this is cubic centimeters, the cubic centimeters will cancel each other out, and we are left with a mass quantity in grams. And I get a value of 87.69 grams of aluminum would be that mass of aluminum. Okay, let's turn the page. Mass percent. Mass percent is if I happen to have a compound and think of a pie chart, okay, the whole thing would be 100%. But if only a specific sliver of it is carbon, what percent of that compound or sample is possessed by just grams of carbon? To do that, also this equation is on your chem helper. Mass percent is simply the mass of the substance or the element. It's a compound divided by the total mass of the mixture, or if it's a compound, the total mass of the compound. So mass percent is mass of the part over the mass of the whole. Okay, so let's look at this problem, and again, pause it if you need to. A 5.25 kilogram bag of mineral is said to be 3.75% calcium. How many kilograms of calcium is in the bag? So 5.25 kilograms is the mass of the whole. If I rearrange this whole thing, the mass of the part, I would move the mass of the total over, and do so with algebra, we'd multiply. So I need to know is the mass of the whole times the mass percent. So 5.25 kilograms times 3.75%. Did anybody catch the issue here? Whenever we have percentages, when we multiply, we have to get it out of its percentage form. What I forgot up above in this percent by mass, and excuse me, is it should also then be multiplied by 100. Dividing the mass by the whole is going to give me a value less than 1, which is the relative percent by mass. Multiplying it by 100 will then convert it into a percentage. So I forgot to put that. So please put times 100 up above in your notes. So mass of the part divided by mass of the whole times 100 gives you the mass percent. Well, I forgot to divide by 100. So 3.75% is actually 0.0375, which is its relative amount. This is the ratio of mass before we convert it into a percentage. So 5.25 kilograms times 0.0375, which is the mass percent in relative form, gives me 0.20 kilograms of calcium. To check my work, I could always take that value, 0.20, and divide it by 5.25, and then multiply by 100, and you should get roughly 3.75%, okay, which is what I got when I went back through and did the mathematics. Might be a little bit off, but that's usually due to rounding. I got 3.8%, 3.75, right about the same percentage. The last thing in this lecture is to look at 3 fundamental laws in this class that we will utilize throughout the year. And the most important of those is the law of conservation of mass. Whenever you balance a chemical equation, that is actually an application of the law of conservation of mass. By definition, the law of conservation of mass says that during a chemical reaction, mass is conserved. We do not gain mass, we do not lose mass during a chemical reaction. It simply changes form, the bonding arrangement changes, we produce new compounds, but the mass before and the mass after a chemical reaction is the same. Okay? Law of definite composition. The law of definite composition says that a compound always has a fixed ratio of elements. Water is always H2O. Well, if I look at the ratio of masses of hydrogen to oxygen in the formula water, I will always get the same ratio of masses. If I look at in a sample of water, water has roughly 11% of its mass is coming from hydrogen atoms. The other 89% of its mass is coming from oxygen atoms. Okay? This is not looking at the ratio of 2 to 1, but is looking at the masses. Hydrogen is much lighter than oxygen. So when I look at a sample of water, it's always 11% by mass hydrogen and 89% oxygen, regardless of the sample. So even if I go to Pluto and it has some water on it, the percent by mass of water on Pluto is going to be 11% to 89%. So I can use that ratio, that constant proportion of mass to help identify what the substance is. Okay? The last major law is called the law of multiple proportions. What this says is we can have compounds between elements that are different whole number ratios. Carbon monoxide is carbon and one oxygen, CO. Carbon dioxide is carbon with two oxygens, CO2. But we'll notice that that ratio is a ratio of 1 to 2. So up above you can see the definition. The ratio of masses of elements will be a single whole number if two elements can form multiple ratios of multiple forms of different compounds. How do I look at this in a more clear way? Because I think that's just kind of like, what the heck is he talking about, right? So if I look at carbon monoxide, when I analyze it, for every gram of carbon in carbon monoxide, there is 1.33 grams of oxygen of mass. In carbon dioxide, in every gram of carbon in carbon dioxide, it is known that there is 2.66 grams of oxygen. Well, if I go ahead and take 2.66 divided by 1.33, what does that give me? It gives me a perfect whole number of 2. And therefore, there is twice as much oxygen in CO2 than CO. And therefore, it's 2 oxygens, or 2 times the oxygens per oxygen in carbon monoxide. We get a fixed whole number when we look at the ratio of masses if two elements can form 2 or more compound ratios. Okay, that's the law of multiple proportions. And those are some major laws that we utilize throughout this unit and throughout the entire year, to be honest with you. Okay, so now after listening to this lecture, I do have a reading on this for those of you that might get better insight by reading and looking at the pictures from the textbook. You might find that very useful. And then you can go ahead and again do the second homework of the year. Again, with this homework, I will supply the answer key. You do not need to give me or show me the answers, because early next week we will have a quiz which will cover these 2 lectures. So keep reviewing this material, do the homeworks, check your answers. If you have any questions, please contact me. Be glad to answer those. But hopefully these are things you've learned about in the past. I'm just bringing them back to the forefront, and I'm assuming you guys will do very, very well on this second quiz of the year. Thanks for listening.